Hello friends, I am Dr. Dinesh Kumar Mishra, Professor Pharmaceutics, College of Pharmacy, IPS Academy, Indore. Today in this episode, we are going to talk about an important title, that is pharmaceutical aerosols. We will start with the general introduction of the topic, followed by propellants, general formulation and manufacturing of aerosols. So let's begin our today's episode with the introduction of this topic. Now come to the module 1, that is introduction of the topic. Many therapeutic active ingredients have been administered or applied to the body by means of the aerosol dosage form. This dosage form has been used both orally and topically. Oral aerosol preparations have been used for the symptomatic treatment of the asthma as well as for the treatment of migraine headache. Topical aerosols have been used to treat dermatological manifestations. Pressurized aerosol products were developed in early 1950. Aerosols are colloidal dispersants of liquids or solids in gases. In general, mists and fogs possess liquid dispersed phases, whereas smoke is a dispersion of solid particles in gases. However, no sharp distinction can be made between the two kinds because liquid is often associated with the solid particles. A mist consists of fine droplets of liquid that may or may not contain dissolved or suspended material. If the concentration of droplets becomes high, it may be called a fog. Aerosols are unique among the pharmaceutical dosage forms because they depend on the function of a container, its valve assembly, and propellants for the physical delivery of the ingredients. The aerosol container is referred to as a pressurized package. The pressure inside the package is created by the presence of one or more liquefied or gaseous propellants. When the valve is actuated, the pressure forces the contents of the package out through the opening in the valve. The physical form of the expelled contents is a function of the product formulation and the type of valve employed. Now come to the definition of these aerosols, how they are exactly defined. Aerosols or pressurized package is defined as a system that depends on the power of a compressed or liquefied gas to expel the contents from the container in a finely dispersed mist, foam or semi-solid. The pressure package is convenient and easy to use. Medication is dispensed in a ready-to-use form at the push of a button. As the medication is sealed in a tamper-proof pressure container, there is no danger of contamination of the product with foreign materials. When required, these systems can be prepared under sterile conditions and sterility maintained throughout the life of the product. When regulation of the doses is desired, a metering valve can be used. Aerosols can reduce and sometimes eliminate irritation over an abraded area of the skin occurred by the application of an ointment and cream. Now, what are the advantages possessed by this formulation? It includes rapid onset of action, circumvention of the first pass effect, avoidance of degradation in the GIT, lower doses which will minimize adverse reactions, ease of convenience of application, a dose can be removed without contamination of materials, medication can be delivered directly to the affected area in a desired form, and application of medication in thin layer. Although they have numerous advantages, but it also possesses certain disadvantages like difficult disposal, difficult formulation, costly and complicated quality control testing, and not applicable to heat. Now move towards module 2, that is components of aerosols. An aerosol product consists of the following components: propellant, container, valve and actuator, product concentrate. Now what is propellant? Propellant is mainly responsible for developing the proper pressure within the container and expels the content when the valve is opened and aid in the atomization or foam formation of the product. Second component of aerosol product is container. The selection of the container for a particular aerosol product is based on its adaptability to production methods, compatibility with the formulation, ability to sustain the pressure necessary for the product, the design and aesthetic appeal, and the cost. Aerosol containers have been manufactured by following materials which withstand high pressures as 140 to 180 pound square inch gauge at 130 degree Fahrenheit. The components that can be used as container material: metal, that may be tin plated steel, aluminum, stainless steel. Second one is glass, that may be uncoated glass or plastic coated glass. Tin plated steel containers are lightweight and relatively inexpensive. For some products, the tin provides all the necessary protection. However, when required, special protective coatings are applied to the tin sheets prior to fabrication so that the inside of the container will be protected from corrosion and interaction between the tin and the formulation. The coating usually is an oleoresin, phenolic, vinyl or epoxy coating. The tin-plated steel containers are used in topical aerosols. Now come to aluminum material. This aluminum is extremely lightweight and is less reactive than other metals. Aluminum containers can coated with epoxy, vinyl or phenolic resins to decrease the interaction between the aluminum and the formulation. Now the aluminum can also be anodized to form a stable coating of aluminum oxide. Most aluminum containers are manufactured by an impact extrusion process that make them seamless. Therefore, they have a greater safety against leakage, incompatibility and corrosion. Another material that is stainless steel. It is used when the container must be chemically resistant to the product concentrate. The main limitation of these containers is their high cost. Second type of material that is used is glass. Glass containers would be the preferred container. For most aerosols, glass presents fewer problems with respect to chemical compatibility with the formulation compared to metal containers and is not subject to corrosion. Glass is also more adaptive to design creativity and allows the user to view the level of contents in the container. However, glass containers must be precisely engineered to provide the maximum pressure safety and impact resistance. Therefore, glass containers are used in products that have lower pressures and lower percentages of propellants. When the pressure is below 25 pcig and less than 50% propellant is used, coated glass containers are considered safe. Plastic containers have had limited success because of their inherent permeability problems to the vapor phase inside the container. Also, some drug plastic interactions have limited the efficacy of the product. To increase the resistance to breakage, plastic coatings are commonly applied to the outer surface of glass containers. These plastic coatings serve many purposes, like they prevent the glass from shattering into fragments if broken, absorbs shock from the crimping operation during production, thus decreasing the danger of breakage around the neck, protect the contents from UV light, act as a means of identification since the coatings are available in various colors. The third component of aerosol is valve and actuator. Valve mechanism is probably the most basic part of any aerosol through which the contents of the package are emitted. Primary purpose of the valve is to regulate the flow of product from the container. It provides a means of discharging the desired amount when needed and prevents loss at other times. Spray valve is the most common used valve. It consists of following subcomponents. Actuator. The actuator provides a rapid and convenient means for releasing the contents from a pressurized container. It allows for easy opening and closing of the valve and is an integral part of almost every aerosol system. It also serves to aid in producing the required type of product discharge. Actuators may be of different types. It may be spray type, it may be foam, it may be solid stream, it may be special applications like throat, nose, eye or vaginal tract. Another part is stem that is usually made from nylon or delrin, but brass and stainless steel can also be used. Another part that is gasket, Buna and or neoprene rubber are used commonly for the gasket material. Fourth part is spring. It serves to hold the gasket in place, and when the actuator is depressed and released, it returns the valve to its closed position. Next part is ferrule or mounting cup. It is used to attach the valve proper to the container. An epoxy or vinyl coating can be added to increase resistance to corrosion. Valve body or housing. It is generally manufactured from nylon or delrin to connect dip tube, stem and actuator. Now what is this dip tube? Dip tube, another part that is made from polyethylene or polypropylene. Viscosity and the required rate of delivery play an important role in the selection of the inner diameter of the dip tube. Another valve type is metering valves. These valves are applicable to the potent medication dispensing and operate on the principle of a chamber size that determines the amount of medication dispensed. Now another component of the aerosol is product concentrate. It consists of active ingredients or a mixture of active ingredients and other necessary agents like solvents, antioxidants and surfactants. Now we will move further towards module 3 that consists mainly of propellants. In detail we will talk about propellants. Propellant is generally regarded as the heart of the aerosol package. In addition to the expel of the product, it must act as a solvent, diluent and to determine the characteristics of the product as it leaves the container. Now propellants, they can be classified as compressed gases. It includes nitrogen, carbon dioxide, nitrous oxide. Another type of propellant, that is liquefied gases. It includes fluorinated hydrocarbons, hydrochlorocarbons, hydrocarbons. Now first we will discuss about fluorinated hydrocarbons. They are widely used in aerosols for oral and inhalation purpose. Chemical name and numerical designated. How we can designate it? First name is trichloromonofluoromethane. It is designated as propellant 11. Second one is dichloro-difluoromethane. It can written as propellant 12. Third one is dichlorotetrafluoromethane. That can written as propellant 114. Next one is chloropentafluoroethane. That can be written as propellant 115. Second type of liquefied gas, that is hydrocarbons. Hydrocarbons propellants have replaced fluorocarbons for topical pharmaceutical aerosols. Their low order toxicity makes them suitable while their flammability tends to limit their use. Now how we can write as chemically and how we can numerically designate it. First one is butane, that can be written as A17. Second one is isobutane, that can be written as A31, and propane A, that can be written as A108. As with the fluorocarbons, a range of pressures can be obtained by mixing the various hydrocarbons in varying proportions. Now what are the physical properties of propellants? The vapor pressure of a mixture of propellants can be calculated by Raoult's law, which states that the total pressure in any system is equal to the sum of the individual or partial pressure of the various components. Raoult's law, which regards lowering of the vapor pressure of a liquid by the addition of another substance, states that depression of the vapor pressure of a solvent upon the addition of a solute is proportional to the mole fraction of solute molecules in the solution. The equation can be written as Pa is equal to Na upon Na plus Nb, Pa0 is equal to Na PO0. Now what is this Pa? It is partial vapor pressure of the propellant A. What is Pa0? It is vapor pressure of pure propellant A. Na, that is moles of propellant A. Nb, moles of propellant B. And capital Na, that is mole fraction of component A. Similarly, it can be written for component B, that is Pb is equal to Nb upon Na plus Nb, Pv0 is equal to Na Pv0. And this equation can be further explained as total vapor pressure, that is capital P is equal to Pa plus Pb, where this capital P is the total vapor pressure of the system. Now friends, we will move towards next module, that is module number 4, that comprises of general formulation of aerosol preparations. But friends, before moving to our next module, I would like to suggest that you must visit our website, that is www.cec.nic.in, for further reading and learning of more topics associated with your B.Pharm syllabus. Here you will find many lectures, e-content, FAQs, LORs and many more. Hope this site will be a catalyst of learning for you. Now come back to our module, that is general formulation. Now this generally aerosolic preparation consists of two vital components. First one is product concentrate. It consists of active ingredients or a mixture of active ingredients and other agents like solvents, antioxidants and surfactants. Second component of formulation, that is propellant. It may be a single propellant or blend of various propellants. The propellant is selected to provide desired vapor pressure, solubility and particle size. Depending on the type of aerosol system, they may be dispensed as a fine mist, wet spray, quick breaking foam, stable foam, semi-solid or solid. Selection of system depends on various factors like physical, chemical and pharmacological properties of active ingredients, site of application. Now we will talk about how many types of aerosol systems are possible. There are mainly 4 types of aerosol system which can be developed. First one is solution system, that is also known as two-phase system. Second one is water-based system, that is also known as three-phase system. Third one is suspension or dispersion system, and fourth one is foam system. Now this foam system can be further classified as aqueous stable foam, non-aqueous stable foam, quick breaking foam or thermal foam. Now we will discuss one by one. First one is two-phase system. What is this two-phase system? It usually contains both the phases, vapor and liquid phases. When drug is soluble in propellant, then no other solvent is needed in this type of system. Based on the type of spray, propellant can be selected. It may be single or mixture of two propellants. For example, propellant 12 and 11 in a ratio of 30:70. Another propellant 12 and 114, ratio of 45 and 55. Now move towards three-phase system. What are these three-phase system? It is generally known as water-based aerosols also. Since propellant and water, they are not miscible, hence forms three phases as water phase, vapor phase and the propellant phase. When water is immiscible with the propellant, solubility can be increased by the addition of co-solvent like ethanol and surfactants in the ratio of or a concentration of 0.5 to 2%. And the examples that can be used as oleic acid, palmitic acid or stearic acid. Now we'll talk about third type of system, that is suspension system. It involves dispersion of active ingredients in the propellant or a mixture of propellants. Suspending agent may be added to the system to decrease the rate of settling of the dispersed particles. Developed primarily for oral inhalation aerosols. Another system, that is foam system. It usually consists of aqueous or non-aqueous vehicles, propellant and surfactants. There are usually four types: aqueous stable foams, non-aqueous stable foams, quick breaking foams and thermal foams. First one is aqueous stable foams. In this type of system, propellant concentration is usually 3 to 4, and in this system dry spray is produced and several steroids or antibiotics that can be dispensed in this manner. Now non-aqueous stable foams, they can be formulated by the use of various glycols like polyethylene glycol. Third type of system, that is quick breaking foams. Propellant is in the external phase and they are mainly used for topical application, and the surfactants that can be used may be cationic, anionic and non-ionic. Other one is thermal foams. They are delivered as foam on the application of heat. The usual example you might be knowing, that is shaving cream. Now friends, we will move towards next module, that is module 5. It comprises of manufacturing of aerosols. Now we will talk about manufacturing of aerosols. It requires specific knowledge, skills and equipments. Like other pharmaceutical preparations, manufacturing of aerosols must be done under strict observation of supervisors, followed by rigid quality control test. Usually manufacturing of aerosols takes place in two stages. First one is preparation of concentrate and second one is addition of propellant. Hence, part of the manufacturing takes place during filling operation, which is quite different from non-aerosolic preparations. The aerosol concentrate is prepared according to general accepted procedures and a sample is tested. Later on, propellant is added and the product is sealed into a container. Now, what are the apparatus that are used for filling of this aerosol preparation? That are cold filling apparatus, pressure filling apparatus, compressed gas filling apparatus. Now we will talk about first one, that is cold filling apparatus. This apparatus consists of insulated box fitted with copper tubings and filled with dry ice or acetone. These fitted copper tubings increase the surface area and cause faster cooling. Now what is the method? The method A, that is product concentrate chilled to -30 to -40 degree Fahrenheit, and this chilled product added to the chilled container and chilled propellant added through inlet valve. Method B, product concentrate and propellant chilled to -30 to -40 degree Fahrenheit and mixture added to chilled container. The valves are set in place and the filled containers pass through water bath, the contents that is heated to 130 degree Fahrenheit and containers dried, capped and finally labeled. Now what is the advantage of this method? That is very easy process, but it is having certain disadvantages, that is restricted to the non-aqueous products and those are not affected by low temperatures. Aqueous products, emulsion cannot be filled, and for non-aqueous systems, moisture appears in final product. Another method that is used for filling of this preparation is pressure filling apparatus. This apparatus consists of metering burette that is used to measure the amount of propellant to be filled. Now what is the method? Product concentrate is filled through the burette at room temperature. Propellant is added through the inlet valve. And the flow of propellant stops when pressure of filling propellant becomes equal to the pressure within the container. Advantages of this method includes preferred for solutions, emulsions and suspensions, having less contamination, less propellant is lost and there is no need of refrigeration. The third method that is used for filling of this preparation are compressed gas filling apparatus. In this method, propellant used is compressed gas, pressure reduced by pressure reducing valve, and that the pressure that is used is usually 150 pounds per square inch gauge. The method is product concentrate placed in container, valve that is clamped in its place and the air it is evacuated by vacuum pump and filling head inserted into valve opening, valve is depressed and gas is allowed to flow into the container. The container is sometimes shaken during and after filling by mechanical shakers. Now LORs with answers. Question number 1. Define aerosols. Aerosols or pressurized package may be defined as systems that depend on the power of a compressed or liquefied gas to expel the content from the container. Question number 2. What could be the possible advantages of aerosols? Aerosols possess certain advantages like removal of dose without contamination of remaining material, delivery of medication directly to the affected area in a desired form, rapid onset of action, alternate route of administration. Question number 3. What are the usual components of aerosol system? An aerosol system consists of following components: propellant, container, valve and actuator, product concentrate. Now friends, it's time to summarize our talk. Aerosol dosage form involves administration of therapeutically active ingredients to the body. These are widely accepted by the patient and physician as advantageous dosage forms. The aerosol dosage form allows for the dispensing of the product in the most desirable form: spray, foam or semi-solid. Depending on the nature of the product, the characteristics of the spray or foam can be changed to ensure the proper and most efficient use of the medication. An aerosol system consists of propellant, container, valve, an actuator and product concentrate. Propellants used generally are compressed gases and liquefied gases. The types of system generally exist are two-phase system, three-phase system, suspension system and foam system. In general, the manufacture of aerosol products takes place in the two stages, as manufacturing of concentrate and the addition of propellant. In summary, this module will help students to understand about basics of aerosols, components of aerosol system, propellants, general formulation and manufacturing of aerosols. Friends, we will back with another episode. Till then, goodbye. Thank you.